All right, so there are some special products when multiplying binomials. So we want to go through and see if we can notice any patterns as we multiply these. So there's three binomials. I want to use the SMILE method. So again, when we do that, first one we'll distribute the first two terms. So notice we have x times x. That would just be x squared. And then we go to the last two terms, which is 3 and negative 3. And basically that's minus 3 squared, minus 9. And now the middle terms we get from distributing the inside and outside, the 3x when we do it here, and a negative 3x. And we notice that those middle terms are opposites. So it would be 0x. So it looks like our answer is just x squared and minus 9, no middle term. Let's try the next one. Again, multiplying the first two terms together, we notice they're the same. 2a times 2a is the same as 2a squared, which is 4a squared. 2a, the quantity squared, I'm sorry. Last two terms, I get 1 times negative 1. They're opposites of each other, so when I multiply, I just get the negative 1. And then the middle term comes from multiplying 2a. I get a 2a on the inside and a negative 2a on the outside. And again, those are opposites, so there's no middle term. So I guess our answer is just 4a squared minus 1. Try the last one. Again, just multiplying the first two terms, 4x squared times 4x squared, they are the same. So when I get that, I get 16 x to the fourth. And then 9 times negative 9 is negative 81. And I'm just suspecting that the middle terms again are going to be the same, opposites of each other. 9 times 4x squared is 36x squared. And when I do the other distribution, I get a negative 36x squared. So they are opposites and they do drop off. So what have we noticed? Maybe this is something that we could use to our advantage next time we see them. So do you notice any patterns in the binomials that we multiplied? So if you look at the binomials, x plus 3 times x minus 3, 2a plus 1, 2a minus 1, 4x squared plus 9, 4x squared minus 9. That's where we have ones adding and ones subtracting. The binomial factors, when this happens, there's a way we can explain it. These are called the conjugates, where we have two terms that are added. So maybe in general, like an a plus b, and then the next one would be an a minus b. So we got one plus and one minus. So when we multiply conjugates, what we're noticing in the answer, there's no middle term. We only end up with the first distribution and the last distribution as our answer. So we never have to worry about multiplying them to get the middle term. So the only answers that we get then, we just multiply the a times a, which would be an a squared, and b times negative b would be a negative b squared. So what we're going to try and do is remember the next time we see conjugates, the only thing we need to multiply is the first distribution and the last distribution. So there's no middle term. All right, another special product is not as nice. That's really nice because we actually don't even need to multiply to get the middle term ever. But the next one is something that we do a lot, and there is a pattern to this too. So again, I'll just go through and with the FOIL method, try and notice a pattern in the binomials. It looks like the binomials are the same in each case, x plus 3 times x plus 3. And when I multiply the first terms, I'm just getting x times x, which is x squared. The last terms, 3 times 3, which is 9. So I'm multiplying the same thing. And then the middle term, or the SMILE, comes from 3x and 3x. And the two terms that we get when we distribute are the same. We get basically double, or we get the same two terms. in the middle, so we just have to take 3x and 3x to get our positive 6x. So we do get a middle term, but the middle term is just double, right? All right, so let's look at the second one. The first two terms, 2a times 2a, that's 2a the quantity squared, which would be 4a squared. Then last two, -1 times -1 is just -1 squared, or plus 1. And the middle two, I get a -2a, and again a -2a. So I am getting the same terms again. So I could just double that. -2a is -4a. The last one, 3x times 3x is 9x squared. -5 times -5 would be positive 25. And then middle two terms, I'm hoping they're the same. -15x, and if we look, 3x and -5 is -15x, so I guess we could just double this. It's the same thing. We get -30x for our middle term. So the binomial factors, if we look at the pattern there, the binomial factors are actually the same. So we basically could say that our two binomials could be a plus b times a plus b. And the answer, we do get a trinomial every time, but the answer we could write out as a squared. So that's the first term. Last term is b squared, so we get perfect squares in the first and last terms. And then the middle term would be a times b twice, or it would be a 2ab. So usually when we see this, instead of a plus b times a plus b, we usually see it as a binomial squared, or a plus b, the quantity squared. And I want us to get good at just writing the answer to this, a squared plus 2ab plus b squared. I don't want to have to go through any work. We should be able to get good enough where we take a binomial and square it, and we should be able to just write our answer. So let's try that. How would that look? These are actually the same binomials, but they're written as a binomial squared. So how do we get the same answers? By just taking the binomial and squaring it like this. So the first thing, we know the first term comes from the first term squared. So we could just square this. We get x squared. The last term came from squaring 3, so that would just be 3 squared, or plus 9. And then if we just multiply the two terms together, we get the 3x, the positive 3x. Now that was one of the distributions that we got before, so we do need to double it. And that's what the formula is basically saying. So I get plus 6x. So let's try that for the next one. When we have a binomial squared, we're just going to take the first term and square it. That's going to be our first term in our answer. So 2a times 2a is 4a squared. The last term squared, -1 squared, is a plus 1. And then all we need to do is multiply the terms together. That'd be a -2a, and then double it. That'd be -4a. Okay, so after a while, again, we shouldn't even have to write the arrows and things. I write these in here, the arrows and the work, to get us a visual on how to basically memorize it. But if we can keep track of all that stuff in our head, then we should be able to just write our answer. So 3x squared, our first term would be a 9x squared. Looking at the -5, I'm just going to square that. That'll be the last term in my answer, plus 25. And then all I need to do in my head is multiply these together, -15x, and then double it, -30x. So again, I want to get as good as we can, as efficient as I can, especially these two types, the conjugates with no middle term, and then perfect square binomials or binomial squareds.